So now let's talk about restores, which is really the whole reason that we do backups. There are three common kinds of restores. First off, one-offs. When someone comes running into your cubicle or calls you up on Slack and says, oh my God, I dropped the customer's table or I updated too many rows. This is by far the most common reason that we do restores is for emergencies. That's what I'm going to focus on inside this module. The other two things that we do a lot are testing your backups, like restoring just to make sure that the backup worked, and then recurring scheduled restores, like when you constantly have to refresh a development server. Number 2 and number 3 are important, but I don't cover them inside this class. There's only so much that I can teach you inside the span of a day. So in here, I'm going to focus on number 1, how to do a one-off restore. The mechanics of it, like which GUI you use, how you issue commands, how you write them out in order, it's going to depend dramatically on how you take the backups. For example, if you use VSS snapshots, if you're backing up your SQL server with the same tools that you back up your file servers, your domain controllers, etc., VSS snapshots, VSS backup software, Veeam, Aperture, etc., they make this really easy because they've got a GUI. And they just list out, here are all the times when we took backups, which one of these would you like to restore to? You choose the one you want and you're out of there. SQL Server native backups are more complex. They take more time. Yes, Management Studio has a GUI built in to help you with that, but that's still only really kind of the starting point. There are probably going to be other things that you want to do with that, and that GUI only works for just one database at a time. The big picture of what you do with native restores is that you decide what's the date and time that I want to aim for, because it's up to you. You can pick any date and time that you want. Then you restore the most recent full backup before that, the most recent differential backup if you're using differentials, and then all of the transaction logs up to that exact moment in time. Now I have one slide on here, right? One slide, and it's like, okay, here you go. If you're going to do VSS backups, do this. If you're going to do full backups, do that. And you're like, well, Brent, I want you to show me all of those. I don't bother doing that because here's the deal. You're going to want to go to the documentation every time that you do this. Every time you do this, doesn't matter whether you did it before 3 weeks ago or 3 years ago, features in backup products change. Even in SQL Server, something that you would think would be fairly static by now, SQL Server, the way that we do backups and restores changes over versions. Great examples of transparent data encryption and how the compression has changed just over the last couple of years. When you have to do it, you have to get it right. You know, your users are standing outside your office or banging you on Slack going, hey, 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 and they're just, my biological clock is ticking like this. So you want to make sure that you get it right. You want to go read the documentation every time. I read the documentation every time because I don't have to do restores that very often. Full restores aren't that big of a deal, but when I want to get to a point in time, like during an emergency, I still hit the documentation every time. So I'm not going to talk about the mechanics inside this module, which commands that you issue in which order. What I'm going to talk about is if you step way back in the big picture, what are things that you have to worry about during each of these scenarios? Because in each of these scenarios, there are some pitfalls that will kind of backfire and catch you by surprise. Let's start with restoring just a few rows, a table, or an object. When I say an object, I mean things like a stored procedure, a view, a function. This, for me, is the most common reason that people, knock my door down and they're like, oh my God, we have a problem right now. I just ran an update with without a where clause, or I forgot to highlight the where clause. And they only want to get certain rows back, or they want to get a specific table back. I find it really strange that even as I record this in the year 2020, SQL Server still can't do this. It's one of the top 10 most highly requested features. If you go to feedback.azure.com, which is where we track where Microsoft tracks all of the requests for SQL Server, I wrote a request to do this years ago, and it's up in the top 10 in terms of requests, and SQL Server still can't do it. Third-party tools can. Back a decade ago when I worked for Quest Software, this is one of the big selling points of third-party backups. Quest Lightspeed, Idera SQL Save, all these tools. I don't really care which one you use. They're all good enough. If you need to restore individual objects frequently, these are fantastic tools. But if you don't have those, what you're going to have to do is you're going to have to restore an entire database and then pull out the specific objects that you want. Never, ever, 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 ever restore over the top of an existing database. Because let's role play for a second. I'm going to tell you exactly how this goes wrong. So I'm going to be a user. I'm going to be all, oh, hey, DBA, I made a terrible mistake. I accidentally dropped a table. Could you do me a favor and restore the customer's table? I don't care which date and time you give me, as long as it's the most recent one you can possibly give me. Okay, thanks. Oh no, you can wipe away everything else in the database, I promise. The customer's table is the most important thing. And you can see what's going to happen. You know what's going to happen is if I try to restore over the exact same database, they're going to be like, but we're missing the last few rows from the sales table. There are a few sales records that weren't in there. So never, ever, ever restore over an existing database. Instead, restore over to a new database name with new file names. You want to make sure that you don't run any risk whatsoever of trying to overwrite the production database, because I've seen people try to restore to a new database name, and then when they run into errors, they start doing all kinds of forces, and the next thing you know, they trash the production database. The people who asked for the restore usually know how to pull individual objects out. So that person who said, hey, Senor DBA, can you do this for me? What you do is just say, okay, I restored the database to a new name, sales underscore from yesterday. Go get the stuff out that you need. You have 1 hour. After 1 hour, I'm going to go delete that restored copy. And you always want to give them kind of a time deadline, because otherwise, next thing you know, that database is sitting around for years and we're backing it up and doing CheckDB on it every single day. Next up in our gotchas, restoring just one database. If someone says, oh, you know what, we totally screwed the pooch on the development copy of the sales database. It doesn't even matter if it's in development, production, disaster recovery. If someone asks you to restore a database, still never restore it over the existing database. Restore it under a new database name and ask them, hey, I just restored that sales database and it's on there as sales underscore from yesterday. Can you go check it out? Make sure it has what you want, because sometimes it doesn't. Like sometimes they don't realize they deleted the stuff like 6 months ago, or the stuff was never there and they made a mistake. After all, this isn't their first mistake today. They've already made one. That's why they're coming to you. Hey, can you just go check at sales underscore from yesterday and make sure that it has the data that you want? When you're okay with it, what I'm going to do is I'm going to rename the database that ordinarily you would have had me restore over. I'm going to rename that as like DB underscore to be deleted. And then I'm going to restore or rename the one that I restored with the right name. This way, they still have both copies online for a brief period of time so that they can work out which pieces they need to pull, like some kind of Frankenstein's monster that they're going to reassemble back into one piece. Now, if that database that they're asking you to restore has any kind of high availability or disaster recovery, if it has replication, log shipping, database mirroring, always on availability groups, any of those features, when you restore a database, you break that in some way. And the way that you break each of those features is different. Failover cluster, you don't necessarily break, but the problem is if it's in a failover cluster, it probably has some of these other pieces in here as well. If you go to restore a database that's in any of those, it gets more complicated because you have to figure out what you broke and you have to reset it from scratch. And I'll give you an example because it's kind of popular, always on availability groups. You can't restore a database that's in an always on availability group. They can't be in the status of restoring unless you're like seeding a replica. So what you have to do is you have to take the database out of the availability group, blow away the original, restore over on top of it, add it back into the availability group, and then seed all of the replicas. So that's why all that stuff tends to be out of the scope in terms of a training class. I'll tell you, it's not in any of my other training classes either. It's kind of a big just red warning flag that if you have any of these, you're going to be hitting the documentation in order to figure out what steps you need to do next. And that brings up an interesting kind of sidebar. When people think about making their databases more highly available, when they think about putting in stuff like database mirroring, always on availability groups, replication, the more available you want your database to be, the more you try to turn up the 5 nines knob, the more expensive it gets, the harder it is to do this stuff. There's no set it and forget it option inside a SQL server for this kind of thing. And this is why one of the reasons why companies want to go towards the cloud. As you go towards the cloud, some of these things are taken out of your hands. You don't do availability groups, database mirroring, log shipping in order to protect the SQL server. Microsoft, Google, Amazon, whoever your cloud vendor is, manages this stuff for you. On the flip side, they also manage the restores for you. And the speed with which you can do restores tends to be one of the things that keeps companies on premises. There is no SLA for how service level agreement for how long it's going to take Microsoft, Google, Amazon, whoever, to restore your databases. So in a truly mission critical environment, my clients who are like, it's got to be up all the time, it can't go down, and when we have an oops query, we have to be able to restore it as quickly as possible. Those are the kinds of clients who still tend to stay on premises so that they can control the restore processes themselves. Just as leaving that out there, because I know sometimes people are like, my skills are terrible, they're useless, I'm not going to be available in the cloud anymore. And this is, if you're good at this kind of process, this is one of the reasons why you do still have a job for the long foreseeable future. So next up is restoring multiple databases. If they tell you, hey, this application involves these 4 databases, can you restore all 4 of them together? Oh, does that sound easy? It sounds really simple, just like if you're used to restoring files, go restore these same 4 files. Now, if you're doing VSS backups, like if you're backing up VMs with snapshots, it works fine because it's snapping all of the databases at almost the exact same point in time. And you're going to be like, what do you mean, Brent? It is the same point in time. There's only one snapshot. There's a catch. Hold that thought. With SQL Server backups, they're done one at a time, serially in order. And they're not all caught at that exact same time. In order to demonstrate it, what I'm going to do is I'm going to take the 3 databases on my desktop lab. I run the Stack Overflow databases from 2010, 2013, and current. I have all 3 of these databases at the same time, or on my server at the same time. So I'm going to back up all 3 of them. I'm using backup to null just because that goes extremely fast. It reads the data, but then it doesn't actually write anywhere. So I'm measuring the best case scenario for backups, just streaming the data out as quickly as I can. I'm going to execute all 3 of these, and then I'm going to look at how long they take to run. See the red arrows down in the results section. It tells you when the first backup finishes, when the second backup finished, and when the third backup finished. They don't all finish at the exact same time. Now here I'm doing full backups. I'm not doing transaction log backups, but the same premise applies. The larger your databases are, the more active they are, the more stuff is in the transaction log, there will be a delay as your jobs, because what your jobs are doing is they're going through all of the databases in order, doing all of the log backups, they're doing all of the full backups. There will be a time delay in between databases. Now in my case, because I'm doing full backups, we're talking about a 20-second to 2-minute range in between these. And you might be thinking, well, Brent, maybe that's because your desktop is slow. No, go look at your own backup jobs and go see how long they're taking. If it's taking you 30 minutes to do your backups and you have 10 databases, you better believe that when you go do a restore, they're all going to be at ever so slightly different points in time. The problem with that is that user transactions can cross databases. I can run a transaction here that says go add a customer into database 1, and then over in database 2, go file an order for them. Go insert an order for that exact same customer. Well, depending on the order of my backups and the way that I do my restores, if I restore both database 1 and database 2, I can have a point where there's a sale without a matching customer, or opposite, I can have a customer without a matching sale. You're probably looking at this and going, oh, well, who would ever write code like this? Oh, the stories that I could tell you. Some multi-database applications like Microsoft BizTalk actually plan for this. Microsoft BizTalk is designed to put a bunch of stuff across different databases, and so they use this thing called marked transactions. They put in marked transactions and they say whenever you're doing restores, you want to restore to a specific marked transaction time. And at that marked transaction, we can guarantee that all of the databases are at the same point in time. That also means that you're going to lose data if you restore to that marked transaction, because other transactions may have happened afterwards. They simply won't be in the restore at the time you go to do the restore. And Microsoft documents and talks through this extremely specifically. Nobody probably reads the documentation. Most applications don't. Most applications just aren't even aware that this is a problem. So when I go to talk to my end users with a multi-database application, that's usually the first time that they've ever heard of this problem. So they are in for a big surprise when I say, hey, look, here's the deal. When I restore, there's a possibility that your transactions are going to have data in one database and not in another. I just want you to be aware of that before you ask me for a restore so that we can start to plan for this together, because this isn't my fault. So you can either change your application to work like BizTalk does, and that's on them. It's not on you. As a database administrator, you don't have the power to change their application to work with marked transactions like BizTalk does. Generally, I'll just hand them the BizTalk documentation and say, would you like to implement something like this? This would be you implementing something like this. They're like, I can't read. And I'm like, okay, yeah, we're going to cross that one off. Number two, I can do my best effort. I can just restore the most recent backups for all databases, but I'm going to tell them this database is as of 9:15 a.m., this database is as of 9:20 a.m., this database is as of 9:25, because we do our backups in order. Just so you know, this is why some of your databases may have transactions in one and not the other. And I can't give you the list of which ones are in there, like which ones are missing data, because SQL Server doesn't work that way. Or number three, I can use the stop at parameter, which says when I'm doing restores, stop all the databases at this specific date and time. In order to do that, what I would have to do is go through, make an inventory of all my databases, and I'd have to find the point in time that's the oldest restore, that is the oldest available restore for each of my databases, and then find the weak link. If I've got, say, a list of 20 databases and one of them's oldest backup is 9 a.m. and the rest are all at like 9:03 and 9:04, then I got to restore everybody to 9 a.m. and just stop there. It doesn't matter if I have additional log backups that go to later times for other databases. I can only go as far as my weakest link went. Then I'm going to restore all the databases with stop at and use that parameter for the specific date and time that it was my weakest link there. It's a whole lot of work, and Microsoft has a write-up on how to go do it, and it really is a whole lot of work when you read through it. This is also one of those examples of why you want to practice your restores ahead of time. If you go to read that knowledge base article when you're in an emergency and you're trying to do a restore, you're going to be like, there's a lot of words here and a lot of commands that I've never really seen before. I don't think I'm comfortable doing that. I don't blame you. I'm not comfortable doing it either. This is why I talk about going to the documentation every time you do stuff like this. But if you're going to do that, if you go in armed with the knowledge that my database has, or my application goes across multiple databases, then this is why when we talk about if you want to turn the nines up, if you want more availability, it's going to take more work. I'm going to have to prep and plan those restores ahead of time. This helps to inform management when we talk about why I have to practice restore so often so that I'll be ready when this kind of thing strikes. Always strikes when you're not looking for it. Next up in our challenges list, restoring system databases. So system databases are master, model, MSDB, and I always say tempDB, but here it doesn't matter because you never restore tempDB. It's just master, model, and MSDB. You probably shouldn't. If for some reason someone put a user object inside a system database, that's a big sign that they probably don't know what they were doing, but it was probably an accident. You don't want to restore these, and in fact, you can't restore these while SQL Server's up and running without jumping through all kinds of hoops. So if someone's coming in to me and saying, hey, Brent, I accidentally put a table inside a system database and I didn't know why it was wrong. Can you restore it for me? I'll say, sure. What I'm going to do is I'm going to restore my backup of the system database to a different name. You can remember restore databases to a different name. If I take the master database, if I need to restore the master database for some reason, I'll just restore it as master underscore restored or master underscore for Alex. So that way, Alex can then go get the stuff that she needs out of there, and then I'll go drop the master underscore restored database. And I'll teach Alex, hey, don't put things inside system databases again, because I can't restore those quite as easily. Bonus points if you go through and patrol your system databases, looking for things that users created. Time for another side discussion. Sometimes if you go out there and you Google, you'll see advice, or Bing, whatever. I support alternative lifestyles. If you Google for advice on what you put in system databases, you'll see a lot of old crusty DBAs saying things like, never put stuff inside user databases. Crusty DBAs always sound like that. Never put stuff inside system databases. It's bad. And this is what they're talking about. This is the reason why it's bad, is because it's harder to do restores. That's also why you'll see those crusty old DBAs be comfortable putting their own utility stored procedures, stuff like SP Blitz, SP Blitz Cache, SP Who is Active. They're comfortable putting those things inside system databases. The reason why is they don't ever restore those objects. They simply, whenever they build a new server, they go recreate those stored procedures from scratch. It's also why with SP Blitz, our system health check kind of stored procedure, with SP Blitz, I warn you when you have objects inside system databases, and you'll see it fire. Sometimes it'll point out things like Redgate SQL backup. Third-party monitoring tools will put stuff inside system databases. They do this because they're like, we don't need a database to do anything. Yeah, you don't, because you're just dumping everything in a system database. I see how it is. It's okay if third-party apps do that, because you would never go restore their stuff anyway. We're really only worried about users putting things in there like, seriously, one time I saw a web application that had done a deployment and put their user and password list inside the master database. So every time a user was created, it got a new line inside there. Every time a user went to log in, it got a new line inside the system databases. And they're like, yeah, we did this accidentally right at the beginning of our application, and we've never been able to correct it. So of course, then they're backing up the master database every 5 minutes. If you do have to restore a system database, let me jump back. If you do have to restore a system database, like if something went horribly awry inside any of these system databases, you probably can't even trust the server. I wouldn't do a restore because something truly went to hell in a handbasket. Great example. I've had SQL Server updates, like cumulative updates and service packs, go terribly, horribly awry and absolutely hose an entire SQL Server and hose some of the system databases. And I'm like, you know what? We should just really, throw a match behind us on the way out the door. We should just cover this thing in gasoline and throw a match on the way out the door. I don't trust anything about this thing. I'm going to build a brand new SQL Server from scratch. I should say too, so jumping back one on here. So there are knowledge base articles about how you restore master model MSDB and how you go about resuscitating resource DB. You don't, some of you, this is probably the first time you've ever heard of resource DB. It's a hidden database that contains some of your system objects. So there are knowledge base articles from Microsoft about how you go restoring these, and it involves doing terrible, ugly things like putting the SQL Server into single user mode. I'm not a fan of that because by the time you're at that point, the server's down, no one else is able to use it. I would rather have you going and building a more reliable SQL Server. If you want to do these things, you can. I know some of those old crusty DBAs are like, every senior DBA should be able to restore the master database. I'm not a fan of that level of trivial pursuit. If you think it's rare to do user database restores, wait until it's time to do a system database restore. That's really rare, and you want to hit the documentation every time. I always want to give people a rough idea of how many times I have to do something, because I don't want you to think that I'm talking down to you like this is something that I do all the time. I restored a master database once 15 years ago, and I'm like, oh, no, 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 no. I am never doing that again. I am lighting a match and walking away from that server every time I ever have to do that. So now, speaking of which, whenever we want to throw a match behind us and walk out, restoring a whole SQL Server to the same place. Like when I say the same place, I mean the same geographical place, like the same data center. The data center around us is fine, but that one SQL Server caught fire and all hell broke loose. If you're using VSS backups, it's easy because this is really what they're good at. VSS backups are taking a snapshot of the entire SQL Server. They don't have to. It's just that that's how they're usually configured, is you take a snap of the entire SQL Server. And then you go into their GUI, you just pick the exact date and time on a timeline that you want to use as your source, and then boom, within a matter of seconds or minutes, you've got a whole brand new SQL Server exactly the way it was at that moment in time. But if you're using, and that I should say too, that's also why I'm such a fan of VSS backups. I know a lot of database administrators don't like these because they take control away from SQL Server. In this class here, we're talking about fundamentals of database administration. You're going to have role models out there in the community and in your peer group, like local user groups, who are going to say, I don't like VSS backups. They take the control away from me. Yeah, it's because they're good and you suck. So these things, they're able to just restore the whole VM to a point in time. That's what I want for someone who doesn't have a lot of time. Whereas if you're doing native backups, like, also to be transparent, this is what I usually do. Because usually when customers bring me in, they want mission critical 24/7. They want to be able to restore to an exact moment in time. They want really high throughput, some things that VSS backups have a little bit of a challenge with in some cases. Just to be clear, I do still use VSS backups. Just most of the time I end up doing this. Rather than restoring a whole SQL Server by restoring its full backups, its differentials, and its log backups, and then restoring the whole SQL Server's OS, well, restoring the OS first, what I'd rather do is just light the match, throw it behind me, and walk out. I'd rather build a brand new SQL Server from scratch. Because let's be honest, if the whole SQL Server was in such bad shape that you had to restore the whole thing, there's probably a reason for that, and I probably don't trust it. Plus, to be honest, I've probably been looking for a reason to build a brand new SQL Server anyway. I probably inherited this thing from somebody who built it before me, and they didn't have any clue of what the hell they were doing. Now this here is much harder work. This is way harder than the previous slide. If I go back to the previous slide, this is a piece of cake. It's just, oh, point in time, boom, we're done with the restores. This is way more work because what I have to do is I have to build that whole new SQL Server. I have to patch it. I have to restore the user databases. If there is anything in the system databases, like my own utility stored procedures, I have to recreate them from scratch. I also have to recreate things like logins, permissions, agent jobs, schedules, trace flags, link servers, the whole list of things that I have to go and recreate. And if I don't have a copy of the original server, I'm going to have a bad day. Because most of us don't remember every login, every agent job, every trace flag, every permission. We just don't have those written down. So that's where you kind of have a little bit of a takeaway and you go, you want to start running SP Blitz today and building out the process that you would have to do to recreate this server from scratch. You want to have an awareness of what's going on this server and how it's configured. SP Blitz is part of the work that helps you get there. The reason why I encourage folks to start thinking about that is that you're taking this training class today. This is really just the starting line of your official DBA career. This isn't the finish line. You're going to be doing restores for the rest of your life. You're not happy about that, but later on in your life, you're also going to be building clustering, always-on availability groups, log shipping, replication, database mirroring, all those things that rely on the transaction log. And you need to be able to reconfigure that from scratch whenever you do restores. When you're doing this, you don't want to wing it. You don't want to next your way through the GUI and then just try to remember from scratch what your SQL servers have. Because this is the starting line in your career. You're going to be working with more and more SQL servers, larger and larger SQL servers with more and more complexity over time. So that's why you want to start using an install checklist. You want to start working off a piece of paper or obviously something in Excel, a PowerShell list, whatever it is. Here are all the things that I need to do to bring a server back from the dead. As I talk about all this stuff, obviously doing this starts to sound a lot more attractive. This is why when I talk about someone who's got 1 to 2 SQL servers, 100 to 150 gigabytes of data on each SQL server, that's why I'm such a raving fan of this. With this, you don't have to know any of that stuff. It's just that with this, you also don't have an awareness of any of this stuff. You don't know what the logins are. You don't know what the agent jobs are. You don't know what the trace flags are, which is kind of a mixed bag. If you just only have so many hours in the day, maybe you don't want to learn what those things are. So next up, restoring a whole server to a different place. Instead of restoring it to the same data center, let's think about restoring it to a different data center. Inside my first responder kit, if you go and download my first responder kit from BrentOzar.com, one of the things that I have inside there is a multi-page PDF, and I like to print this out and give it to executives, and it says, for each of these situations, each of these 4 situations, high availability, disaster recovery, corruption, and oops queries, for each of these, how much data are you willing to lose and how long are you willing to be down for? I'm not going to cover the details of that inside this presentation. I have a whole separate session just around RPO and RTO, recovery point objective and recovery time objective. And we dig way deeper into that in the mastering classes. But you pick out the numbers differently for each of the columns, and one of the columns is disaster recovery. We lose our network switches. We lose our shared storage. We have a fire, a comet hits the data center. We lose all our domain controllers in one data center. When this hits, when we're doing disaster recovery, we're usually restoring our SQL server to a different place, like a different availability zone, a different region, a failover data center. If you're doing VSS backups, this is really easy because what you can do is you can sync your VSS backups from one place to another. All those third-party tools, Veeam, Zerto, they're all able to sync their databases in near real time or sync their backups in near real time from one place to another. So if you want to light up your production data or your production SQL server over in a totally different data center, it's relatively easy. You go through the GUI, you check a couple boxes, and off you go. With SQL Server, though, that's different. Because with SQL Server's backups, and what I mean by if you're using SQL Server's native backups, you can totally do the top one with a SQL Server, and I highly recommend it. It's fantastic. But on the bottom side, if you're using SQL native backups to product your server, You have to go build a brand new SQL server from scratch. You have to patch it. All those things that we just talked about a couple of slides ago for restoring a totally cratered server in exactly the same place. So now you can kind of start to see that, oh, Brent, I'm going to have to be doing this multiple times under duress. Sometimes I have to do it to restore a SQL server to the same place. Sometimes I have to do it when I do disaster recovery. And when you're doing disaster recovery, it's never just one server. When you're doing disaster recovery, it's lots of servers at the same time. I know some people, sometimes I'll talk to clients and their database administrators, and I'm like, hey, have you ever tested restoring over to a different data center? And they're like, oh yeah, we did it once. It was about 6 months ago. And I'm like, okay, so how long did it take you? Oh, I think it took us maybe about an afternoon, about 3-4 hours. And I'm like, great. Now imagine all of your stuff needing to fail over to that other data center at the same time. Imagine we lose your primary availability zone. Imagine we lose your production SAN. How quickly are you going to be able to get all of the servers lit up in a disaster recovery data center? They're like, wow, that could take, hours or days or weeks. Exactly. That's where automation comes in. This is why I'm a huge fan of, if you're a production database administrator and you've decided that you want to do this for the rest of your life, go learn PowerShell and use the DBA tools framework. DBA tools is an open source PowerShell toolkit that gives you all kinds of commandlets to do things like syncing agent jobs between servers, syncing login jobs or logins between servers. It was originally started by a couple of community members who needed to move a SQL server from one place to another, and they're like, oh, sweet potato, this sucks rocks, and it does. So they wanted to build PowerShell stuff in order to make your life easier for that. I don't teach that here, because in my weirdo consulting job, I only work on one SQL server at a time. But if I had to go back and be a production database administrator for a data center full of stuff, like half a dozen SQL servers or more, I would learn this in order to make my life easier, especially during disaster recoveries where I need to fail over lots of SQL servers quickly. So to recap what we talked about inside this module, when you're doing one-off restores, hit the documentation every time, because you're probably having to do something that you haven't had to do before. Maybe someone wants just a few rows this time. Maybe someone wants a whole database. Maybe someone wants groups of databases. Maybe they want to use the stop at command. So I need to be aware of how this works every single time it runs. The more often you do it, you still need to hit the documentation, because you're going to fall into the trap of thinking you know exactly what you're doing. That's when things get bad and people start restoring over the exact same database that they actually needed to keep online for a while. If you're going to take the journey of being a production database administrator full time, and you don't want to focus on performance tuning servers, you want to focus on keeping them up and running, which is what production database administration is, then start preparing for server level rebuilds by learning PowerShell and DBA tools.io.